Hi everyone, welcome to Kotlin London. This is Enzo, I'll be your host for today, and behind the scene there's Publisco to make sure that everything runs smoothly. I'm not sure if you'll be back to the office like I have, for a few days at least. But yeah, if you're still like around and we're working Kotlin, last month we have a great panel with people talking about like remote working, how it can be effective in this world. So check it out on YouTube, of course. But this month we're back to the original format with two great talks. Um, if you haven't already, of course, please join our meetup page, hit subscribe on button on YouTube, and don't forget to follow us on Twitter at Kotlin London. And if you know someone or if you might be interested in giving a talk, please let us know. We're always interested in having speakers. So just for our sponsor, thank to 47 Degrees for sponsoring the Kotlin London. Please check their training on their pages, the courses, and there's a link in the description below. As I said, we have like the usual format with two talks. We have to thank you, of course, for joining us and sharing the knowledge. As usual, we have a short Q&A after each talk. So you can post a question straight in the YouTube comment with the hashtag ask, and we show them at the end of the talk. If you share, ask a question with the hashtag, don't forget the hashtag, you'll be able to participate in the raffle that will be held at the end of the talks. And you might be able to get like a IntelliJ license or a yearly subscription at Moshi. What is Moshi? Is where I work, first of all. But it's an app that lets your kids, if you have kids, to get better at sleep at nap time, but also to meditate and basically to relax. It's a mindful app for kids, and he has a lot of great content. And we'll be able to give some yearly subscription for free. So just one more thing during the talk. The talks, please share your encouragement with emoji or a short feedback on the chat, not just like questions. It's always helpful for the speakers to have a short feedback and not talking to a void, like it's unfortunately it is when we doing things online. One day we'll be hopefully we'll be able to do it in presence. We're working on that. We'll be sharing a survey to understand exactly how do you feel to go back to in-presence events. But so far, we're still like, most of us are still in London, but we're still on remote and we're still doing online. I think that's it for now. For me, we can get started with the first speaker. Well, actually, first speakers. It's a talk. It's a joint talk from Attila Blenesi and Anders Ha with a very hot topic. You always request. I'm talking about KMM, so multi-platform for Kotlin. So let me introduce them. Thanks to Attila and Anders. Let's introduce it with a KMM story. And Attila, Anders, the floor is yours. Thank you.
Hello, folks. Welcome to this Kotlin London session. Hope you've all been enjoying your day so far. A little bit of a quick background about us. So I'm Anders, an iOS engineer at Sophia, which is, I guess, rare to see at these events. And I'm also joined by my colleague Attila, who is our Android engineer. So we are one mobile team of 5 engineers, one team in the sense that we have a unified workflow and also a collective ownership of this Kotlin Multiplatform AppCore for our mobile apps. So it makes a perfect segue to the agenda of this session. So firstly, we'll have some corporate talk on why and the how of a Kotlin multi-platform for Sophia. And then we will talk about a slightly unconventional core architecture of ours. And if you are into the idea of marrying unidirectional data flow and data persistence together, it might be of interest for you. And lastly, we will end this session with a dessert of resources and a sample project that were made for this architecture. So let's get started. So Sophia is a group chat service with a very conventional information architecture where we have kind of a user group feed that fans out to user-created chats. So it's somewhat of a writing on the wall for us that there is an uphill battle against all the challenges and incumbents in this social space. So alongside all the innovations in our product, we also hope to achieve as much parity in non-functional requirements as possible, like availability of the service, instance response time, and also fault tolerance in certain user actions, while trying to stay within the means of being a small team. So in our opinion, it is the different preferences or balances in all these non-functional requirements and goals that leads to different outcomes in mobile tech stacks across the industry. So the first crucial question we ask ourselves when we figure this out is that whether we are a thin or a thick client. And the analogy of a thin client, in our opinion, is that the client contains almost no domain logic, either by a deliberate decision or by the nature of the domain. So, for example, apps that are mostly content-driven or that they are online only usually fall in this category. So, for example, apps for utility companies that just for you to review your bills and pay your bills online, or some more niche setups like the email service, hey.com, for example, with their entirely backend render UI. So we obviously don't want to build Sophia as a thin client because to compete in a lot of these non-functional requirements, we have to be investing in client-side logic in order to achieve them. But in any case, thin client is where we consider like Kotlin multi-platform might not make sense. So let's think about it. Like if the client is thin, there's not much of a domain logic to be shared, and therefore, like Kotlin multi-platform is unlikely or very unlikely to offer your team an edge in terms of the technical stack. An example, in our opinion, is that say when you are very happy with a stack that have, for example, a Polo GraphQL client in there, where most of the user flows can live off, straightforward queries and mutations without much additional logic to them. In this specific case, like the GraphQL client itself probably have already carried out most of the benefits you could have for shared core benefits in the different GraphQL client SDKs for different platforms. So in some ways, to be an OTP, that's a critical question if you have a thin client. But on the flip side, if your domain have non-functional requirements like offline availability, like network traffic efficiency, goals, or response time requirements, especially when your service has to deal with large or unbound collection resources from your backend systems, most likely your apps will be on the thick client side of the analogy, so as we think the Sophia app is in. And the thick clients are where we think Kotlin multi-platform shines the best, and it suits our use case also very well. And to be more specific, when we look at the statistics of our current code base, 30% of it is platform agnostic, but also business critical to us. And it's business critical in the sense that it maintains a local persistent domain, it does all the synchronization logic with the backend systems with specific niche synchronization models for specific domains. And it also does all the aggregations and queries and mutations work for each and every UX flows. And so 30% might not sound prominent, But let's not forget that the other 70% is very likely to be your familiar breakfast of UI and application glue code. And in other words, this 30% part of the app can be way more logically complex than the rest. Of course, also depending on whether your backend designs and needs. But then in our case, it's definitely the case. And for us, having to invest only once is a huge win, because sharing this complex core allows frees up our development time for optimizing the platform UI experience, and also to be able to pursue more platform integrations. It also somewhat helps the delivery risk for us, since we no longer need to build the domain twice on 2 different stacks, while we can have a very focused test coverage on the KMM core, which is somewhat like killing 2 birds with 1 stone. And finally, it's worth to recall that, at least minimally speaking, Kotlin multi-platform is merely a 2-chain of a compiler, a build system, Gradle, and the platform libraries that are being directly exposed in the language. So when we compare it to some other cross-platform stacks, right, we have somewhat avoided kind of an astronomically larger dependency on the cross-platform UI application framework that they provide. And it is very often the case that these solutions have to play catch up with their target platforms, either in terms of the exposed functionalities from the platform frameworks themselves, the UI conventions, or in some cases, performance. And in our opinion, we also think that the cost equations has somewhat tilting away from these cross-platform UI solutions, and that's because we all know that all these decorative UI options that are on the rise on both iOS and Android, Jetpack Compose and the Swift UI in this case. So now you may say, enough abstract corporate talks. So may I present the 3 things that we think Kotlin Native does better than some other multi-platform technologies. So first and the most important thing, it has to be the bidirectional interoperability with Objective-C. So let's take a step back and think about why Kotlin and Swift, despite being new languages in this decade, have managed to grow to where they are today. The developer productivity boons that we get from them in terms of improved expressivity and usability is obviously playing a huge part in that. But the most significant factor is perhaps that they offer all these on top of complete access to the ecosystems that they're part of. That means all the application and UI frameworks written in the incumbent language, Java or Objective-C in that case. And you can use, say, Apple UI Kit or Android support library in Kotlin and Swift directly without any obstacles. And we're also not talking about just basic interoperability through C, where you need to do all these memory management yourself, retain objects, release objects, or say doing an Objective-C method call through the Objective-C runtime yourself. And it is the full-fledged integrations that between the language runtimes that's the key in this interoperability. So in the case between Kotlin and Objective-C/Swift, it is, for example, like Kotlin interfaces can be implemented by Objective-C classes and also vice versa. And this type integrations is what enable greater flexibility in abstractions and your architectural designs, which is also important in enable incremental migrations, or even just deploying the technology in whatever scale you prefer, while also giving us close to native developer experience, since the Kotlin native product is not going to be too different from Objective-C products from the iOS project point of view. And in our case, the interoperability enabled kind of a multi-platform abstractions of both our a network, our Google Cloud File Store, and also login stack abstractions, where their iOS implementations are mostly written in Swift, and also using optimal iOS platform libraries underneath. So the second thing, in our opinion, is that it operates with the same shared memory multi-threaded model across both platforms, and this is what all Android and iOS developers are familiar with, of course. And we think it's critical because computational heavy tasks are somewhat inevitable in tech clients. So being able to offload them from the application main thread in a cheap, configurable, and efficient way is important. And the bonus point being Kotlin coroutines being able to fit the bill brilliantly. Though, of course, currently there are two big caveats. There's the straight memory model of Kotlin native, which fortunately is on its way out. There's also another caveat in case you're contemplating targeting Kotlin JS, which is the web worker shared nothing model. But then today's talk is about mobile development, so we'll spare that burden from you. And so the very last thing is that Kotlin native is relatively non-intrusive. Of course, there would be a fixed cost of integrating the toolchain into your build systems, and also having to bring in, for example, the Kotlin standard library into your binary. But then the cost of them is fairly minimal. And in exchange of this deal, what you get is all the flexibility to go small or go big, just doing small parts of your app, or maybe the entire app too, however you like it. So from an iOS project perspective, it can be as simple as a friendly Objective-C framework. So now that we have gone through the why, let's move on to the topic of how, more specifically, how we planned and executed the KMM move. And it can be summarized as three high-level steps. The first step is perhaps to assess your architecture. We look at both our architecture and stacks across both iOS and Android stacks. Specifically what similarities they have, what is needed to be converged across both of the sets to make it happen. In our case, we are all well-versed, as in both Android and iOS teams are well-versed in the functional reactive programming and also unidirectional data flow. And our stacks have a similar clean architecture style layering. So convergence part is relatively straightforward. So one key of success in our case, we think, is the high modularization. Our module boundaries often goes down individual flows of screens, and we are also actively trying to avoid huge intermodule data dependencies. Another way to put it is that we think modules should only exchange identifiers and their procedural outcome, rather than through the main objects between themselves. Because I mean, think about just like, after all, each of them should be able to, get the full domain objects or whatever data they need through the domain layers themselves, right? As long as they have the minimal amount of data, like in identifiers of certain domain objects. In any case, this modularization has greatly helped containing the migration impact, especially we have to split our apps into very small migration tasks and execute them on a more irregular basis. So once the assessment of your architecture has been completed, it can be started with a small proof of concept. So at this stage, the goal should be to prove that the Kotlin Multiplatform Core that you're planning to do can be integrated well into both stacks architecturally, and also the build systems respectively, or whatever build pipeline that you currently have. And proof is the keyword here, because the hello world example should never be sufficient for things like this. This is also the time where you should try to test out all the intricacies of Kotlin and Objective-C interoperability, and also preparing solutions for them. It's also a good time for trialing the workflow, since with this new one mobile team vibe, since this library is going to be under collective ownership with process or another suggestions is possible. It's possibly to trying to showcase tangible improvements while staying in scope. If you need to secure further stakeholder buy-in. In our case, throughout the whole migration process, we have regularly demonstrated the impact of the Kotlin Multiplatform Core by, progressively showing that the offline availability of all our features and flows constantly expanding in the app. And that is obviously comparing against our currently previously online-only experience. So now, with the proof of concept done, most of the architectural wheels should be in place already. So in our case, we just went full steam ahead with kind of a three-track approach to the migration, where multiple migration strategies are being employed. There is first the big system migrations as a very first track at the top, where there are large cluster of features or domain logic that has to be done all together and deployed in one go. We also have normal product feature work in the middle track, where some of them are not actually being done in KML core, and initially we'll expand on that later. And there are also some side quests at the bottom where there are smaller deliverables that are less critical and can be migrated on the site when we have time. So obviously we started with the proof of concept, as mentioned. And then after the proof of concept, this is followed by this big migration deliverable of our home real-time feed experience. And this is especially crucial for us since this part of the domain would be pulling a lot of data in that is necessary for us to do all the backend listening automatically with, and it also prefetches a lot of data for many subsequent flows. In any case, our design goals for all these big system deliverables is drop as we go, in the sense that all the old stack of these migration deliverables should be replaced completely at the end of it once the Kotlin multi-platform replacement of them is ready. And sometimes, though, edge cases did exist for them, and they require temporary APIs to be introduced somewhat out of place in the system until their natural home in the final Kotlin Multiplatform Core, those parts of the system are eventually migrated. In any case, now you might ask, what about all those new features that need to be delivered on the live products and cannot wait for this months-long big system migrations? This is when a parallel development strategy should be employed. And so before implementations of every new product feature began, we do sit together and discuss whether it could have been, say, 100% AppCore Kotlin multi-platform based, or whether it is blocked by an in progress or part migration deliverables. And one prominent example would be all the new messaging features that are additive to our live chat product, and that happens somewhat before and in parallel to when we're developing the Kotlin multi-platform version of our persistent chat domain from a clean slate. And clearly, as shown on the roadmap, that the new chat domain will be months away when we have to deliver these features. We do all of them against the old production stack, independent of whatever efforts that we're doing in the Kotlin multi-platform project. And this chat domain only catches up with all these new features in its later mature stage in the development pipeline. So with that, as we go deeper in the journey, I will start to build the new product features directly in this Kotlin multi-platform AppCore. In one specific case, our group event organizing tool introduced a new oscillator to backend domain, and it just so happens that the project started when there's no more migration blockers on the project. So we are able to make it like a Kotlin native baby. And aside from product features, more and more of these side quests were unblocked along the way when we do all these big deliverables. And they were taken care of during the feature development of time. And these deliverables were generally covering screens with fairly isolated API flows of themselves, or screens that are at deeper levels that are less frequently visited. So among these deliverables, one honorable mention is the mobile mono-repo initiative that we have. Whether or not your mobile teams will share any code for any kind of stack, we do think there's a merit to have a mobile mono-repo, which is a passive way to tear down silos, since both mobile teams are somewhat doing similar work in terms of implementation. And obviously, in a Kotlin multi-platform settings, having a mono-repo means that it's easier to introduce cross-validation checks for any changes you make in your Kotlin multi-platform code base against both apps. But most importantly, it freed our Android devs from passively tracking the development of this Kotlin Multiplatform Core in the iOS repository. And that's done for Git modules. How excited. So yes, you might ask the question, like, are you really having this Kotlin shared library being incubated in the iOS repository? Yes, and now you may wonder why. The subjective answer here is that every side of the relationship needs to give in order to take. So in this very last section, before us talking more touchy architecture stuff, here are some suggestions on how you can approach developers and win their hearts over. No money back guarantee, of course. So, it's worth stating that the mutual benefits of Kotlin multi-platform, being unlocking developer time for native user experience and things like accessibility, and also further platform integrations, for example, like rich notifications or out-of-app sharing experience on both iOS and Android. Feature lead time might also become more uniform, since all your complex domain logic no longer has to be re-implemented twice for both platforms. You also now have twice the manpower to pull off domain-level tooling improvements like reusable abstractions, primitives, and also unit testing tools. The bonus point is, of course, domain-level bugs being patched once and fixed everywhere. What an awesome feeling. And all these small savings would add up in the long run. And because of that, instead of pushing a utilitarian angle like using Android code in iOS, which sounds boring, we could perhaps reframe it as, say, sharing a legacy. Use it as an opportunity to review, to evolve, and to converge architectural practices from both teams. Try to build it as a we, and using it as a knowledge sharing exercise. And especially if you're like us, having been practicing all these same patterns on both Android and iOS stacks, you're likely to have little to no hard time navigating today's Kotlin native, even with today's strict memory model still in place. These are also patterns that are highly interoperable with all the decorative UI frameworks on the rise on both platforms. should you want or have already been using them. Last but not least, try to prioritize reducing friction for the iOS team. Remember that the iOS team will have to give a lot to forge this relationship. That includes riding a new learning curve, having to learn and work with more tools in their daily workflows, despite the language being familiar, and also having to accept some of the intricacy of a Kotlin native. And this is the answer to the question of why the Sophia AppCore was incubated in the iOS repository. We deliberately choose to prioritize to preserve the fast build test run iteration cycle in our Xcode projects. And we think this is integral to a comfortable daily development experience for our iOS developers. And also because the iOS part of this deal is currently subjected to random surprises from the straight memory model. In addition to that, keeping them close to the iOS app also allows rapid iterations in earlier stages of the project, especially on how the API should be designed around Kotlin to Objective-C export limitations, and also Objective-C import limitations in Swift. So if you are committed to have a mobile mono-repo regardless, then do it first and bon voyage. So this marks the end of our corporate small talk, and now we'll move on to the AppCore architecture at Sophia. So off to you, Attila.
Thank you, Anders. So now let's get more technical. I will start with sharing more about how AppCore actually works. So AppCore is our shared brain, is an intimacy embedded in the mobile application between the UI and the presentation logic, between the UI and the backend systems. It contains all the critical domain logic for driving the mobile user experience. We don't repeat ourselves while halving the implementation and the ongoing maintenance risk. This gives us consistent behavior and feature parity across both of our mobile applications. All of the mobile team members are expected to understand and contribute to AppCore for the purpose of planning, delivery, and estimations. AppCore work is inherently part of both Android and iOS efforts. So let's see more about how this local domain is actually built. So the internal domain is based on SQLite database schema and JSON models. This gives us flexible options depending on the anticipated local querying and filtering needs. AppCore internally is a unidirectional data flow architecture, practicing common query responsibility segregation. All transactional writes or operations are carried to AppCore's operations. They are managed by an operation queue with the duplication and throttling options. These operations have serializable inputs and output requirements in order to support persistent operations and cross-process communication. Use cases and store actors are free to read or listen to changes in this SQL core. A collection of use cases, interactors from clean architecture form the public API of AppCore. These use cases are modeled after a specific UI screen flow they are representing. This also includes the shape of the data they expose to the presentation layer. Several collections of store actors, each which interface with one backend system, form the other side of the equation. These harmonize the differences across backend systems and are responsible for adapting to or from the AppCore domain. This gives us flexibility in both supporting and isolating different API operational models. So we have dependency inversion at both the use case and the store actor layer. Firstly, the local domain can evolve without breaking the UI. On the other hand, the actors are swappable to support parallel implementations or breaking changes in the backend systems or schema. But let's see an example. So here we'll be talking about implementing one of our features, which first started with Kotlin Multiplatform. It was events. And you can see here the use case that is responsible for providing all the information and actions that we need to implement this feature. The first function that you can see in the use case is summary API, which gives us a stream of information that will be displayed on the screen. The summary will contain the event date, title, description, and all the necessary information that we need to display on the UI. Then we have functions that represent the actions that the user can take. So let's go into how we will actually implement this summary API. Here you can see a new concept called data source that we built in AppCore as a standard building block for managing entity collection queries with backend APIs. This provides a reusable implementation that handles all the caching concerns: hit behavior, mid behavior, time to invalidate, refetch, toggling, polling, etc. All for you. Most importantly, it is oven ready and ready for use. So how does this look from the presentation layer? When accessing a data source, you can listen to the state changes, and it gives you a 3 states of failed, loading, and value. But it also provides actions for the UI to influence the data source's behavior. For example, it provides a refresh now method, which can help you by force refresh or retrying if the initial fetch failed. We have more complex data sources implemented. For example, we have a paginating data source, which also has actions like fetching the next page or fetching the previous page. But let's go back and see how this actually works in the larger system. So the use case or our data source implementation enqueues an operation, and then it listens to changes in the domain layer in the database. transforming those to the shape that we need to provide to the presentation layer. So in the implementation, as you can see, we provide the operation for fetching the event. We provide the necessary input for identifying the event that we want to fetch. Then we define the query that we want to listen to. And finally, we set a mapper that will transform our domain layer event representation to the summary that we need to display in the UI. But there is another half that we didn't discuss up to this point. So we managed to enqueue the operation, but someone needs to action that operation. And this is where our actors come in. Store actors are responsible for executing specific domain actions or behavior. Each actor generally defines a trigger scenario. It can process actions or, for example, changes in the database. It performs domain actions responsible for in our case, fetching the event. And then optionally, it can update the domain, update the database. So looking at the implementation here, we define the triggering scenario to be our fetch event operation. Then we take our operations input and in this case execute GraphQL query. And finally, we use the result to update the database. So we went through and saw our first function implemented, which provides the data for the screen. But now let's see what remained in our use case. So we have an action that the user can make, and that's RSVP functionality. The user can select if they are going or not going for the specific event. Implementation of this use case will be extremely trivial again. As mentioned, we just enqueue a specific operation with specifying the input of the event ID and the selected response from the user. And then we can transition into the implementation of this. So here, I would like to introduce optimistic behavior as a concept. So we allow and created higher level function that lets us handle optimistic actions. It lets us push results early to the user, minimizing the response time or completely eliminating loading indicators from our UI. The optimistic behaviors let us apply changes to the database before an action is executed. Then it, as you can see in the example, similarly to before, executes another GraphQL mutation in this case. And then it lets us handle both success and failure cases as we see fit. So all in all, this AppCore system gives us flexibility to adapt to more changes or system on the backend side, but also we managed to offer offline support, data persistence. We managed to implement optimistic behaviors, improving our application's user experience. And finally, this significantly increased the knowledge sharing between our mobile teams. So the final point that I wanted to mention is that currently we are actively working on a sample project that will be available in the link you can see here later this week. This will implement a paginated list of notifications from the GitHub API, allowing you to see how these pagination and also optimistic actions work with our AppCore system. So that would be all, folks. Thank you for listening to us. And let's see if we have any questions.
You're muted. You're muted.
Sorry, I was muted. Live issues. Thanks for your talk. Really interesting. And we have a lot of questions. It's a hot topic and a lot of interest in it. So we can go through all of it quite quickly, because otherwise we're running out of time. Let's start. Yeah. Okay. So I think you kind of like already answered in the during the talk. So how do you change team structure? I mean, there are more people working in iOS and Android UI, shared code with Kotlin.
The short answer, as a theme throughout the presentation, is that we kind of combine into being one mobile team, and that the shared layers is under collective ownership. So it becomes, and of course, there's still specialized engineers on the team where, you know, Android devs doing Android UI, iOS devs doing Android, iOS doing iOS UI. And also because we also use our more specialized tools. For example, on iOS, we have more like niche UI libraries that we use that is maybe a little bit foreign from Android devs, right? But then it's the domain part where it becomes a collective ownership, where it is up to the product feature team to decide who is going to do that, or do they split it up across themselves or whatsoever. So the core here is we unify the process, we become, we work on the same repo, and we become one team in that sense. If that answers the question.
Okay. Another question. I think there's been mentioned the talk from your experience. How is for iOS devs to contribute to the shared Kotlin code? Tips to involve them more without forcing a new tech stack on them.
So I guess recalling like part of the presentations, right? It is important to find, you know, what is comfortable for both of the teams when you are heading into this direction, right? And in our case, since we use fairly familiar practices, you know, what is, you know, more you know, patterns like, you know, directional data flow, which is quite recent in terms of popularity, right? So things like this kind of are skill sets that can be carried across any languages, right? So as long as you're able to converge on most of these, you know, more conceptual ideas, then the language itself is honestly, let's say 90% similar, except with the whole generic system rules around that. But then, yeah, I mean, it does take some time to learn, but in the end, it's mostly, as long as the high level concepts and stuff, architectural stuff are converged, then yeah, learning a new language is less of a problem in the grand scheme of things.
Okay, nice. So next question, so follow up, how do you split the common work of an upcoming feature between iOS and Android devs? Actually, are you splitting feature? So are you splitting feature team? So, and it's just like everyone is mobile, so you do a feature. So it doesn't matter if you're Android or iOS. It's just like a feature.
Yes.
Nice. Cool. Yeah. That was the point basically, is just to blend to just one mobile team. Nice. So next question. Did you at any point regret making a transition to KMM? Was there any technical challenges with KMM that made you rethink about the decision?
Do you want to add, or I can just continue going on?
Yeah, please.
Okay.
Okay.
So, like the lucky thing for us is, despite all the current limitations of Kotlin Native, we have all these practices that we've been doing that can thrive fairly well on these limitations, right? Like because functional reactive programming, for example, encourages immutability, and therefore, because of that, we are not quite bound to the strict memory model of Kotlin Native. So in that sense, I don't think we ever regret moving to Kotlin multi-platform. We are very happy about it because we do really see a productivity wins from it.
Nice. And also good to hear from the iOS part, because for Android devs, it is quite common to be like enthusiastic about Kotlin, of course, but from an iOS, so yeah, okay, we actually did it. They commit to this, and we're fine with that. So it's good to hear about it. So yeah. Okay, next question. So in the monorepo, how do you handle releases? Do you use Git flow or something else?
Is that Git flow?
We use trunk-based development, and this was something that both of I mean, it started already by on the iOS team. We on the Android side has used Git flow before, but when we merged the repositories into one, we aligned to the trunk-based development.
Yeah, but then I guess it's worth mentioning that we treat releases, like the release trains, independently. So like the iOS is still tagging its own train of releases while Android does its own. This is especially viable in the sense that because the shared library in Kotlin, Kotlin Monorepo itself do not require versioning in this setting. So we basically just have the apps releasing on their own schedules.
Nice. So next question, to go quickly. Do you require bridging APIs on iOS to make the shared code more consumable?
We do have, excuse me, we're running a little bit, but okay. So we do have a thin bridging layer that takes all these, Kotlin coroutines stuff into the functional reactive programming framework that we use on the iOS side. And also, in some cases, take some of the, say, steel class hierarchy and bridge it, kind of wrap it into a more convenient Swift enum forms for us. So there are indeed some of these thin layers of adaptations, but in a lot of places we basically just use the imported API as is from Kotlin through Objective-C import. And I would say they aren't perfect, but for say 90% of the cases, they are doing the job quite well. Especially if you are if you are fine with immutability in that sense, and they're doing great.
Cool. So in case of destructive action in your use cases, do you still use the optimistically approach?
So it depends on what the backend API supports, or whether we think there is a value of making them optimistic. But then we indeed have cases where destructive actions are optimistically reflected, and then and obviously that is slightly more complicated because we need to adjust the local domain to track what is being optimistically deleted, and then we also need the logic to roll them back in case the actual API request has failed. But we do that, yeah.
Nice. So in the optimistic paradigm, do you track the percentage of operations that were reverted versus the successful?
No, we haven't really collect this kind of analytics, but it would be interesting to collect them to see what will happen. But I mean, we do have that somewhat implicitly, as in the user impression events from the actual UI level analytics framework against whatever backend analytics events that we have, so we can somewhat derive that too, if necessary.
Great. I think we have just one more question. So how do you compare between Flutter and Kotlin, more specifically why Kotlin multi-platform? I would say, did you consider Flutter in the first place?
The honest answer is no, we haven't considered Flutter. As we said, we want to have a performance native UI that is done natively, and also we want, as a product, there are a lot of things that we need to integrate with the systems. A lot of I mean, this is an Android talk, but then there's a lot of a lot of different iOS extension points that are requiring to write in natively. So in that sense, we have to pursue a path where we try to minimize the cost of those business critical domain logic while we're trying to put more investments in delivering great native UI. So
yeah, and being in Kotlin London, that was actually the right answer. Thanks. Thank you so much. A lot of thanks for from the chat. So great talk. Really interesting. A lot of interesting discussion. So thank you so much. Hopes to see you again. Let's say quickly to the second speaker, which is Anton Arhipov from JetBrains. He's talking about Kotlin, Idiomatic Kotlin. Sorry about being a bit late, but it was a very interesting discussion. So up to you, Anton. Yeah, Anton, you're muted. Can you unmute yourself? Sorry about that.
Oh, yes. Thank you.
No worries. Can you start again just briefly? Thanks.
I didn't say anything important yet, so that's,
okay, cool.
That's fine. Yeah, so I was about to say that we were going to talk about Idiomatic Kotlin today, and I wanted to introduce myself. My name is Anton, and I work for JetBrains as a developer advocate, and I'm located in Tallinn, Estonia. You can follow me on Twitter if you wish to. I tweet a lot about Java and Kotlin, obviously. I work closely with Kotlin team about various activities around Kotlin. I'm a developer, like a Java developer in the past for about 20 years, I think. And for the last 10 years, I've been involved with all kind of developer tooling, and that's basically why I ended up at JetBrains as a developer advocate as well. So let me start with the presentation. So we're going to talk about idiomatic Kotlin today. And what is idiom? Idiom is like a small recipe for implementing a task, right? It's not a pattern, like a design pattern or anything like that. It's sort of a small construct that implements some sort of a small recipe for a given task. We actually collect those idioms in our documentation for the users to learn and learn how to actually develop in Kotlin in an idiomatic way. And we received a lot of feedback from developers who would like to have this kind of a style guide. Well, we didn't put much effort into it before because Kotlin is a relatively new language. It's but now it's already 10 years of Kotlin. So this year turned 10 after the announcement in 2011. And we thought it's a good time to actually invest more into it. And we are working on improving the documentation and improving the style guides, developing best practices. The community grows, so there is a need for something like this, for developing the style guides and best practices around this language. Obviously, since my background is Java, and well, I've been a Java developer, and like lately I switched to Kotlin for a few years now. The things I'm talking about here is more like tailored for Java developers, obviously. So if you are Java background, it will be easier for you to understand the material, but it's not required, of course. So if we speak about idiomatic as a notion, it means that we use the expressions and the language constructs in some specific manner, which feel native to the language. It doesn't matter if it's a programming language or a native language, or like human spoken language. There is always some constructs in the language that feel native, right? Like idioms. And if we speak about the programming language specifically, it means that it conforms to commonly accepted style. So the community has came to a conclusion that this kind of things or these kind of things are better implemented in some specific way, and therefore they develop into idioms. And the idioms are good when they make the effective use of the language. So you should get some sort of a benefit of using those constructs, right? Either the code is more performant, or it's easier to read, or it's more concise. Like there might be different criteria for that. So I'm going to walk over kind of quite a few features in the language and see how they combine together in many cases. In many cases, it doesn't make sense to speak just about the feature in isolation. It's very common that for composing an idiom or programming recipe, you use multiple features together. So I'm going to kind of highlight the central feature, but it's often that the central feature of the language that I'm going to speak at some point of time is combined with some other features, and therefore they combine those idioms that are easy to use and make programming more efficient. So we start with the functions, and I think it's a little bit maybe too obvious, but it's so obvious that it's not obvious anymore that functions are a good thing in the language. The thing is, in Java, we don't have higher order functions, right? We have to put them into the classes, and well, in other languages it's not like that. In some other languages you have higher order functions, and therefore it's not kind of a big deal. But coming from Java, you immediately recognize that your programming style starts changing after you realize that you don't need to create a class every time you need a function. So what gives? We have a function, we can call a function from a function, we can use functions as parameters, we can specify all kind of functional arguments in the signatures, and so on. So it leads to the fact that we just use functions and no classes, and start programming a little bit differently and structuring the applications a little bit differently. So instead of grouping into the classes, like in conjunction with the other features from Kotlin, like that lead or result in more shorter programs compared to Java, of course, we start grouping those kind of functions into the files instead of classes, and then we actually end up with a bunch of files, right? Instead of a bunch of files per classes. This is like a normal structuring in Java projects, right? You have a class. In many cases, you have a class per file, and here you just start thinking more of how you group those functions into files instead of classes and class per file. So if you look at the project structure of an average Java project, you can see Kotlin icons there in the project tree, but it basically is the classical structuring of a Java application. And you have like a hierarchy of packages, and in each package you have multiple files, and most likely you have a class per file grouping. And then if you start using this higher order functions more often and grouping them into the files, you suddenly realize that you don't need to separate this functionality by classes. You start grouping them into the files, and your project structure becomes simpler. Suddenly, you probably will end up with some of the code that is just in the files and some of the code within the classes, a class per file, but it might be, caused by some infrastructural need. Let's say you're using some sort of a framework that requires you to use classes. And if you're using, let's say, Java framework like Spring or Java EE and so on, you most likely will end up with this kind of structuring. But even those frameworks lately have been moving away from this requirement, and you may end up with something like this, and you will see that you have a package, and then you just have files, and in files you have this whole functionality in either in functions, and sometimes you start adding classes as you need to model the domain, right? So once you need to model something, then you start adding classes. But if you have just the behavior, you don't really need classes anymore. And with this kind of structuring, you start thinking, hey, maybe I don't need this long package name, and you just have a single package called application, and or however you call it, and have those files in that folder. That's it. It's not so obvious for the Java developers when they migrate to Kotlin, actually, but it's quite obvious for the developers who come to Kotlin from other languages like Python or Ruby, for instance. Okay, that was like a brief introduction. It obviously is not like a huge deal that we talk about functions, but it's just the beginning, right? Functions are the fundamental block for simplifying the applications. And I will be talking about functions a lot here in different contexts. And in the context of extensions, if you are a Kotlin developer, you probably have already learned that you can create all kinds of extensions, extension functions, and extension properties to the existing classes. And there are consequences, like when you're using this. So the consequences, of course, are simplifying this, but simplifying your code. But let's take a look at the example here. So when we come from Java, we want to keep functions or put functions into some classes, and we learn that there is a companion object which is sort of a static context for your code, right? And you create a class string utils, as you have learned before in your project, and you create this companion object to create the static context for your function. It looks kind of messy a little bit, but familiar. So you learn later that you can use objects to create static singletons, and you think that it's better in a way, but reality is that we can actually just keep the higher order functions and pass in the parameter, or maybe if we work within the context of that object that we actually are using, we can get rid of the parameter and use the extension functions instead. So that's also a nice way to implement something in your application. There's like a debate over whether you need to use the extension functions or member functions for a specific class. In my specific example here, I'm adding extension function for the string. Obviously, you cannot add a member string for or member function to the string class in your application, but sometimes even if you have the control over the source code of the existing class, it actually makes sense to use an extension function depending on what you want to do. For instance, if you are creating like a local function to the specific context where you just only there you want to use this extension function, and you don't want to pollute the API of the existing class, it makes sense to actually create extension function for the specific context. Like, let's say you only want to use that in a specific package, for instance. Some companies even implement rules like that. They say, okay, if you create an extension function, it should only be used within that package where it's declared. Something like this. But the style guide does not actually say, or it does not require some specific rules. So you can create extension functions anywhere, and you can use them anywhere. But it generally is a good idea to have rules for this kind of things. It's just that we don't dictate the rules here. I see mostly that teams are creating rules for themselves. And where the extension functions are actually applied. So if you have used Spring, or you are using Spring today, and you know that Spring is is supported by Kotlin, or supports Kotlin pretty well, you will be happy to discover that there are extensions provided by Spring for Kotlin developers to make the API more friendly. So I give you the example here. So for instance, if you have used Spring, you know about JDBC template. It's the API to make queries to the database. And there are multiple different methods in the JDBC template called query. So query is a kind of an overloaded method that takes different combinations of parameters. And here's a simple example where we pass in a string as a query, and then we provide a mapper. There is like a row mapper interface where we say, okay, the ID, we retrieve the ID and the text fields from the database, and we map them into a message class. And then we need an ID to actually make a query. So it's a prepared statement. And if you look at this example, we have 3 parameters for the query method. And well, we first write the string. At the second position, we have this mapper. At the last position, we have the query parameter. The thing is, let's say in here, we can grasp it with the eyes immediately, right? But if you have a long query, it will be like, let's say, half of the slide long, and then maybe you select a dozen of different fields for this query. You need to map them. So the mapper code will be also like half of the screen. And then you have the parameters. The thing is, the query string, which is the first parameter, and the parameters for the query will be like multiple rows apart. So to actually map them with the eyes, like which parameter goes where, will be quite, let's say, inconvenient. And it would be good to have those parameters one after another. So we could have like a query string and then a list of parameters. But in Java, it's not possible because this function, this method specifically, is implemented in Java. And the last parameter is actually var arg, variable length argument. And in Java, we should have them at the last position in the parameter list for the method. In Kotlin, it's not required. We can have var args wherever in the arguments list. And we can actually, yes, that's the original API from Spring Framework. But we can actually switch them in Kotlin. So we don't need to have var args argument at the last position. In Kotlin, we also have single abstract method type conversion. So we actually can remove this row mapper declaration and just declare it as a lambda. And if we have lambda as a last argument in the parameters list, we can actually move it out from the parenthesis, and it will look like we are calling a query method with a string, which is a query itself. We provide a list of parameters. In this case, it's just the ID. And then we have a callback as a lambda written after the invocation. And it looks very idiomatic. It looks very like a domain-specific language for this specific case. And if you read Kotlin a lot, then you will see many places where it's used, where you have lambda at the last position of the parameters list, and it's written outside of the parentheses. So this function is actually an extension function in Spring Framework, and Spring provides quite a few extensions for Kotlin developers as convenience functions to use the APIs more idiomatically. So since we are already talking about extension functions, it's a good place where we can look into the standard library for the scope functions. I think it's also like a very popular feature, and most of those scope functions are actually implemented as extension functions. Obviously, you can learn about them in the documentation. We have a long page describing the use cases and providing the examples. I want to highlight a few cases. So my favorite one is actually the apply function. So the use case is that when you need to initialize an object, and in Java, like in Java way, let's say in Java style, you would declare a variable, and then you use that variable to access the properties, to assign them. With apply function, you can create this variable and don't repeat it. Just use the apply function and pass in the block, and within that block, you will have access directly to the properties of that specific object on which you are calling the apply function. So that looks pretty nice, and but we will get back to apply function in the end of the presentation, because I think there are a lot of use cases for it. The other one, basically the declaration looks like this. If you look at the signature, you can actually spot an interesting construct in there that is called lambda with the receiver, or you can actually find it in documentation by the name functional literal with the receiver. So we get to that one a bit later as well. Another scope function, which is often used in combination with a safe call operator, is let, right? So it doesn't really matter what it does here. It basically executes a block of code usually, but it's just, I see that it's a small idiom that is used quite often for checking if the object is null or not. So here is the example. We retrieve an order. We check if the order is not null, and then we do something with that order. But in this specific example, we don't need the order variable itself. We need a customer property of that order. So if we use let instead, we can actually directly access this customer property of the object from this implicit variable within the block. So it basically means that we get rid of the intermediate variable there. There's like a big hassle over which function should I use for which use case, and in the documentation we provide a table, basically like rules for which function you should choose for in which situation. I'm not going to walk over the rules here. I just wanted to point you at the place where you can learn about it and give you a few examples in the previous slides. So, but well, with great flexibility, you can actually get yourself into interesting, fancy situations. So my colleague Tagir, who is actually an IntelliJ developer, was posting this funny picture. So yeah, you can get fancy with all those extension functions. So and there is no like a good style guide about them. It has a good documentation, but there is like no best practices like developed in which situation you should actually use them. People just use them deliberately again, and sometimes end up with the fancy situations like this. Obviously, this picture is actually, or this code is taken out of the context. It's rather like a small piece of code surrounded by the other code, and without that other code, this piece of code looks funny. That's why the picture is here. All right, so we talked a lot about the functions, and functions take arguments sometimes as parameters, and it's a nice feature there, having default argument values in the language. And let me show you why I think those two features, the default argument values and name parameters, are a good combination. So first of all, we use overloading in Java quite often, and for the most cases, it's because we don't have default argument values in the language as a feature. So for the most cases, actually, you can get rid of overloading the methods or overloading the constructors just by having default argument values in the language. However, like, okay, we can use the function like this, right? So if there is a default value, we don't need to provide it. And in this very simple specific example, the flag, whether or not the file should be searched recursively, is in the last position. So it's very convenient to amend it when we call the function. However, we may have something like this. Let's say it's even simple enough. You have 5 arguments. You have a figure, and you want to keep the default values for the sizes, for the width, height, and depth, and you just want to change the color and the description. And those arguments are, not in the first and the second position, but rather in the last and last 2 positions. So if we try calling it like this, it's a compilation error, right? We cannot do that, but named arguments actually solve this problem for us. And with this, we actually make our code even more readable, because we don't read the code always in the IDE. It's obviously convenient to read the code in the IDE, but we sometimes are forced to do code reviews, let's say, in the browser. And with this feature, we actually make it equally readable in the IDE and in the browser as well. I like that very much. So the thing is, the default argument values basically remove the need for overloading the functions and constructors for the most part, not entirely. And name parameters actually make this feature more accessible for us. Let's talk about expressions. So I give you a small example here. It's a very naive code. We can read and understand it, of course. It's the method that takes a parameter. Let's say we adjust the driving style according to weather conditions. Maybe it's a game, maybe it's a autopilot or anything like that. And I will do small transformations and see where we get with that. So, for instance, we can lift the assignment out of the if expression, right? Like this. And because if can return a value, it's an expression. It's not just a statement compared to Java. And we can inline this variable. We can transform it into a expression body syntax. We can put everything we could put everything on one line. It would be like almost like a ternary operator already, but here I just remove the explicit type specification, for instance, and remove the braces, and I end up with one-liner. And there is a good place to ask whether or not this code is good enough. Well, is it concise? Of course it is. It's as short as it could be. Maybe with ternary operator, it would be even shorter. But is it readable? Well, it actually depends, and it depends on the situation. So, for instance, if we cover the right-hand side of this function, basically we will not read whatever is written inside the logic. It's virtually impossible to say what does this function return, right? Because of the type inference, and it's a source basically of unpredictable situations depending on how you change the logic. So the general rule of thumb is that if it's a public API, please use the type declaration or return type declaration for the functions. If it's a private API, well, it generally is okay to use type inference, but there are situations where you don't want to do that. If we proceed further, let's say we replace the if expression with when expression. Instead, for this simple situation, it looks like equal transformation, but we may have different weather conditions, not just sunny and rainy, but we may have something else. And the good part of this is that if we use when expression with sealed classes, again, we have multiple features combined for the specific case, right? So if we use when with sealed classes, enums or booleans, and we don't cover all the options for this input, for the when expression input, it's actually a compilation error. And well, obviously the IDE helps resolving it and adding more branches. So it's a good idea. It's a good idea to use one expression with sealed classes for basically guarding your the main logic. Let's say you're adding new command, new type of command, or a new type of product or anything like that, whatever your model is. And then you need to implement the handlers for this type of class or the new type, and then the compiler would immediately tell you in which places of the application you actually need to fix this, and that's a very good feature. Since it's a very good feature, we decided to improve it a little bit in 1.6, and by the way, 1.6 release is coming very soon. The release candidate should be coming this month. And in 1.5.30, we actually expanded on the when expression a little bit. The thing is, when you use expression, meaning you return some value, this is like a construct where the compiler actually knows that it should be exhaustive, right? So for the specific cases with sealed classes, enums, and booleans, if we know that something is not covered, some option is not covered with the branch within the when expression, the compiler can throw an exception. or like the error. But when we don't return anything and we use when as just a statement, then the compiler doesn't know if it's exhaustive or not. And before 1.5.30 or 1.6 that is coming, the compiler would, not even the compiler, but the IDE would show you very weak warning that you maybe want to cover all the cases. But actually in 1.6, it will be a rather strong warning, and maybe even in 1.7, it may become a compilation error. So this will force you to actually cover all the cases within the when statement if you are using sealed class, Boolean, or enum as a parameter. And to make it exhaustive, you need to either cover all the cases or have an else branch. And some teams actually decide for linter checks that prevent using else branch if you use sealed classes or enums with when expressions or when statements. It's a good practice, I think. It makes your code more fault tolerant for the changes, but we couldn't make but we couldn't require you like to cover all the options within the when statement from day one, because it might be that you have to cover like 20 branches. The code becomes like messy a little bit with all the options written out. So it's more practical with the else branch. Okay, like try as an expression body, basically the same thing. Try can return a value the same way as if or when statements or when expressions, so we can actually use them the same way. A little bit about null safety. I think this is the most important feature in Kotlin, actually. And if I was considering switching from Java to Kotlin, this is the single feature why I would get a benefit. Like the syntax sugar sometimes is not a benefit for developers. Like it just looks nicer. Sometimes it looks more readable, or maybe too advanced. It actually brings some cognitive load when reading the new constructs from the new language. But null safety is something that brings real value to the table when switching from Java to Kotlin. It's if someone is not familiar, in Kotlin you can have nullable types denoted with a question mark, and when we say that, hey, this value might be null, the compiler will actually check if we verified if this reference is not null, and if we didn't verify that, then it's a compilation error. And basically it's the thing that would drastically decrease the number of null pointer exceptions in your Kotlin applications. But it's not a silver bullet, because in many cases you will be using Kotlin in conjunction, let's say, with Java libraries or any other Java types. Let's say if you have a combined source base, source code, intermixed Java and Kotlin source within the same project, it's not a silver bullet. It will not remove magically all the null pointer exceptions from you. So, and here's just the example. Someone tweeted when they played with Java and Kotlin in the same project, and then the compiler did not catch the possible null pointer exception. And when you run this code, it actually throws the null pointer exception. The thing is, the Java types are treated as platform types, and for the platform types we say, okay, they might be null, but we are going to ignore it, because otherwise you will have to do null checks everywhere. It's just a bridge, right? So there is a bridge between Kotlin and Java, and you have to acknowledge that if you're invoking Java from Kotlin, then you might get null pointer exception. We cannot check that. Otherwise, it will be just impractical. In your source code, we'll have just null checks everywhere. So it's not enough to give the language feature or like just at the type system level. You need to provide some sort of tools for actually working with nullable types. And instead of checking for nulls with if expressions or if statements all the time, we have this safe call operator instead that actually simplifies working with this kind of situations. And Elvis operator is also the feature that combines really well when working with nullable types and nulls, like as in general in Kotlin. So there is also an operator for the same, let's say, topic when we may have nulls, and we are pretty sure that it will not be null. So the compiler thinks it might be null, but we are pretty sure it will not be null. Then we came up with this double exclamation mark kind of assertion that I claim this value will not be null. Please, it's fine if you throw the exception there. And this kind of syntax is chosen deliberately, so it will look ugly and you will immediately spot it in your application and try getting rid of this. So where I see this kind of code mostly is that in the situations where you have a value that is definitely used later than it's initialized, but it's not possible for the compiler to actually tell that. Usually it's the code that belongs to some life cycle, let's say unit tests with JUnit or Spring, like some Spring related code quite often. So generally it's a good idea to go to late init instead, get rid of the nullable type annotation, and then just use the value as it should be, like not nullable at all. The Elvis operator actually plays well with the nullability as well. So we may use it to, let's say, assign default values. We here in this example, we retrieve some person, and if it's null, then we assign a default value, for instance, or use the Elvis operator to return and throw something in the function. For instance, we can replace these two statements like this, right, with Elvis operator, and the function becomes shorter, more concise, even more readable. In combination with nullability, it's not exactly connected, right? We like safe cast operator is something else than the nullability, but it can produce a null value, right? So if we use the safe cast operator and the operation does not succeed, so there would be like a class cast exception. Instead, it returns null, and we already know how to work with nulls, right? If it's null, then basically the expression will be false here, and if it's fine, if the value is not null, if the cast succeeded, then the expression will succeed as well and return true, or it will do the real comparison. Okay, we talked about functions, and just invoking functions or passing them as parameters is a good like combination within the language, but sometimes you need more. And the thing is, we can pass them as parameters, and this parameter needs to have a type, and obviously we declare them as function literals, which are functional types, and we need to have means in the language to work with functional types. It's not just enough to have them as such in the type system. So here is an example. We have a function that takes a functional type as a parameter. We call it like this by passing in a lambda. In this specific example, takes no parameters, and the Lambda takes no parameters and returns some value. And the first step is actually, or like the first good practice that I see is actually on your logic level, on your domain level, extracting those functional types into meaningful names with type aliases. So we already have like functional types in combination with type aliases. And therefore we can, create more meaningful signatures, give them meaning, and it's much easier to read. We understand that the function, this sum function, actually takes the other function, which is an action. Okay, so we have the type alias, but like, is it enough for us? For instance, in your code, you may have some sort of a collection of functional types, and you use this collection to register actions. For instance, it might be some framework that registers handlers. It might be some handler that registers, some button clicks or whatever. In this example, I want to show you that actually you can derive from type aliases because it's a type, right? We can actually derive from it and use this new type as parameter, so we can instantiate it, and basically it becomes like a we, as a super type, we have a function and we can derive from a function. And then it's interesting because why would you do that? And because like the list of parameters is the same, and it's just playing with names to give some interesting behavior, maybe a little bit different behavior in this invoke operator. But generally this behavior should be different depending on the number of parameters. And since it's a functional literal, usually we implement the behavior like when we invoke the function as a Lambda. So it's unclear why would I derive something from the functional literal as such. Thing is, we can actually provide extra parameters in this new type. So if you had the original functional type that doesn't have any parameters, right? This action type, for instance, and we need to have some extra parameters depending on how we use this derivate, then it's a good idea to actually re-implement the constructor, right? Or implement your own constructor providing extra parameters. In 1.5.30, we actually implemented like a missing feature. Now it's possible to derive from suspending functions as well. It was actually needed in some frameworks where they register handlers as suspend functions, and some users wanted to have their own handlers implementing the functional literals with their own parameter list. So it's now possible to derive from suspending functions for those specific cases. Okay, so the general observation that I wanted to make here is that it's not enough for the programming language to actually provide higher order functions as a feature. It's very important to actually give the other tools or other features that would support this, working with higher order functions in the language. And we can make a general observation out of this one as well. It's not enough just to pack the language with the features. It's very critical to make those different features play well together. So we should provide extra tools within the language to work with the specific features. Ranges. Let me see. I try to accelerate, not to keep you too much online, but I think I'm almost done. But I will talk a little bit about ranges. It's an interesting feature in the language, and you can, use ranges for various checks, whether or not, let's say, a character belongs to some range within, the alphabet, for instance. Here, we can convert it to the range check like this, saying that, hey, there is a range from A to Z, and we want to check if the character belongs to that range. For those who are concerned about the performance, sometimes I get this question. Actually, the compiler generates pretty much the same code as if it was without the range. So Kotlin C compiler can actually generate pretty much equal code that Java C does. So there is no huge penalty for that. But what I really like about the ranges is that it's not just about numbers or characters. You can implement your own comparable, type, and use ranges for that. That's a interesting example from the documentation I have found, where you implement your own custom class. Let's say you have a major, minor version modeled like this within a class, and then all you need is to implement the comparable interface for this new class, and then you will be able to use the range operator and also use the range check operator as well. Obviously, we can use ranges in loops, but it's not always clear. For instance, it's sometimes confusing for people if the second argument of the range is inclusive or exclusive, let's say. So it's a good idea to actually use operators, the extension functions for the ranges. So for instance, until it conveys the meaning of the range a little bit better, but it's still sometimes unclear whether or not the size is inclusive or exclusive. So I think this kind of style is a little bit better to use indices. So we just say, please iterate over all the elements of the arguments. Or if we want to iterate by counting them as well, we can use with index function. The story with ranges is a little bit, let's say, it's not as obvious still sometimes to some people. So we try to improve our tooling around it, so that the IDE would hint you what actually to which element you will actually iterate in the range. So the IDE will display additional hints in the upcoming version for the ranges, whether or not the indexes are inclusive or exclusive. Destructuring, it's also a good feature paired with data classes. So for instance, pair is the standard library class, right, which is a data class, and it's a good feature to have data classes, but you can apply them for various things in your programs, not just keeping the data, but also returning some meaningful domain, let's say, object, and still be able to destructure it within the same declaration, right? We call this named num function, and it returns a data class, and we can use this destructuring construct to assign the values with one-liner. Well, behind the scenes, of course, it's possible due to component functions, if you know about them. Basically, if we in a few slides we'll see why it works like this. So for instance, this print map function example, we can see how destructuring works in the loops. Instead of declaring or going over the map items and then referring to every single property from that item, we can actually destructure it within the loop immediately and have access and assign to those local variables in place. Let me skip this one. So this all is possible thanks to the component functions. If the type or the thing that we're trying to destructure implements these functions, then it's possible to destructure. The last thing in my talk, I wanted to talk a little bit about the standard library, and I had a big example here, but I think it's we have spent too much time, so I'm going to skip the example. I'm just going to give you some pointers for the standard library, and it's a good place where to make a shameless plug. So if you go to our blog, and you'll see what kind of blog posts we are currently producing for you. You will see a lot of idiomatic Kotlin posts, and this is the place where the team puts some effort in making you aware of not just the language syntax and constructs, but also the standard library. Because in many cases, you have the scenarios already implemented as standard library functions, and you just should know how they work and apply them. And this will make your programs much shorter, and you don't need to write the code that is already written by someone else. Also, the same content actually is pretty much duplicated within videos. So if you prefer watching videos, we have a YouTube channel where we produce different series of videos, specifically here on idiomatic Kotlin or about the standard library or any application area, for instance, Kotlin for the server side. Let me skip the example here because it's a longish one, and instead I will jump to a few things that I wanted to show you from the standard library. 1 second. So for instance, like in the standard library, there's a lot of functions or extension functions for the, let's say, for Java types or for collections specifically, that are related to iteration or filtering or anything like that, like common tasks that you need to do in your code. So for instance, here, if we need to filter the list of objects by the type, let's say we want to filter out or keep only those objects that are strings, we can use that filter function. But in fact, there is also a filter is instance function. And why did we add it? Because actually it preserves the type of the element in the list in the resulting list that we want to return, right? So in case of filter function, we just stay with list of any objects, and with filter is instance, which is parameterized, we will get the list of the types that we have declared. In this specific case, it's a string. Also, the very nice feature of the standard library is also related to collections and working with lists and all kind of collections, is the compare by and order by function. In this specific example, you see that it's very readable. We want to sort persons based on the name and the age, and this compare by function is a good helper for that. Instead of implementing your own comparator, you can just use the standard library function. And same for grouping, for instance. So instead of writing this code with a mutable map where we try grouping the URLs or like the requests by the URL, we can use this group by and just say that we want to group the elements by the URL. There are some interesting functions for math. For instance, the squares in function So instead of checking whether or not the value falls into the range and trying to adjust it, if it's less than the minimal element or minimal value of the range, it will become the minimal value, or if it's greater than the maximum value, then we assign it as a maximum value. We can just use the coerce in function to implement the same, and it also comes from the standard library. I mentioned that I want to come back to the apply function. Maybe we'll not spend too much time here still, but the thing is, with the apply function, you can actually adjust the existing APIs. Let's say you're working with Java APIs, or you have a part of project written in Java, and with apply function, you can actually adjust it so that you can create your own custom builders first, and then abstract them out into domain-specific functions, which leads us to domain-specific languages instead. So there are good examples of domain-specific, small internal domain-specific languages in existence. Even if you go and look into the standard library, for this is a small example here, right? We have a build string function, which is almost like a domain-specific language for building strings, and it's actually just a wrapper around string builder. Or we have a library called Kotlin X HTML, and it really looks like a domain-specific language for generating HTML documents. Or Ktor, which is a web framework, and if you look at this specific code, we have a DSL for building the routes, and there is also a snippet of code that generates HTML, and it looks like we are using two different domain-specific languages in the same file, but it's actually all Idiomatic Kotlin. And basically, the enabler for this kind of things is Lambda with the receiver. Remember, I mentioned it before. So we talked about extension functions, and we talked about a little bit, I mentioned extension properties as well, but lambdas are functional literals. Basically, they are functions the same way as normal functions, and it means we could create receivers for them as well. So why don't we have extension lambdas? It's just a little bit weird name, so we decided to have fancier name like lambda with the receiver, or functional literal with the receiver. So if we abstract out this apply function a little bit, we can create our own extension functions on the specific object, let's say, or on a specific type, and then those blocks of code that we want to abstract and put into the body of the new domain-specific function can be declared as lambda with the receiver, so that the block of code that we put into the this DSL will actually execute within the context of the specific type, or the specific reference, object reference. Okay, it seems it's like the end of the story, basically. The thing is, DSLs is not the goal for Kotlin. The use of different language features enabled by the Lambda with the receiver leads to this, situation where it's easy to create DSLs in Kotlin. So I hope that it was useful today. And if you want to get the slides, especially with the example from the standard library that I have created, but I didn't show to you, it's already on Speaker Deck, so you can find it there. And thanks for attention. And if you have any questions, I'm happy to answer as well.
Hi. So great talk. A lot of useful tips. Some that I already know, some new for me. So it's really, really good. And well, you can join us for the second part. So you have still a lot of slides to show. So anytime, absolutely. We have one question, so we can quickly go through it unless coming other question in the meantime. So in which situation would you recommend using sealed classes over sealed interfaces?
Sealed interfaces is a relatively new feature in Kotlin, and mostly they were created because of the Java interoperability. So Java in the latest versions added sealed interfaces, so we had to have this feature parity for the interop story. For the style, I wouldn't take the responsibility to recommend something right now, because I honestly don't see like the use case, like the pattern. Like there is no developed pattern for the situation yet.
Okay,
Like
cool.
the obvious need from that is that it's a sealed hierarchy of types. You're playing with types, right? In most cases, if you don't have any behavior attached to the declaration, it probably is fine just to have it as an interface.
Okay, cool. And thank you so much. So again, it was really interesting, and I hope to have you back soon. So I know that you have other talks. So yeah, really
Thank
hope
you.
to come back to you. Thank you so much. Bye, Anton.
Bye bye.
So we still have one thing, so which is the raffle. We can quickly go through the raffle because I'm aware of the time. So let me see if we can get the raffle in the screen. Pablo, if you can put the raffle on the screen, we can quickly go through it. That would be great. So in the meantime, I would like to thank you, our speaker. It was great to have them. Really good talks. I hope they have like a interesting stuff for you. So yeah, let's go through it. And just remember, for the winners, you can email us if you win. Oh, the first winner is Robert. Congratulations. You can send an email to kotlinlondonmeetup@gmail.com and tell us if you want the IntelliJ license or the subscription to Moshi. The second winner, can spin again. Let's see. We should have a drum roll for this. I always forget about drum roll. William Burton, congratulations to you as well. Again, send an email and tell us if you want IntelliJ and or the Moshi subscription. Yeah, that's it for the raffle and the wrap up. So thanks again for joining us. I hope to be back soon to some in-presence events. We're working on that. We'll let you know soon if we can organize something. But yeah, hoping to do it as soon as possible. Thanks to our speaking again. And remember to watch our talks on the YouTube channel. We are reposting also the old talks for the past few months. There's a lot of great content. So yeah, just go and have a look. From Guillermo, Amar, Pablo, and me, stay safe and see you next time. Bye.